What if everything you've been doing in the gym is in completely wrong order? Did you know that simply changing exercise sequence can alter muscle growth by up to 300%? A shocking study from the University of São Paulo has overturned every conventional wisdom about gym training. After comparing two groups performing identical exercises in different orders for 12 weeks, one group gained 35% muscle mass, while the other gained only 12%. Today we reveal the complete secrets behind exercise sequencing that creates these dramatic differences. The physiological mechanisms behind exercise order. Exercise sequence decisively impacts muscle growth through complex interactions between nervous system, fatigue and energy systems. During the first exercise, the central nervous system reaches maximum activation, while neurotransmitters dopamine and norepinephrine peak. In this state, muscle fiber recruitment maximizes, completely activating even type 2X fast twitch fibers. However, as training progresses, neurotransmitter depletion causes muscle fiber recruitment ability to drop dramatically. Therefore, the first exercise in your sequence receives the greatest muscle growth stimulus. ATP and creatine phosphate systems also show completely different patterns based on exercise order. The first 10 seconds are dominated by the creatine phosphate system, allowing maximum power output, but afterward, the glycolytic system takes over with significantly reduced peak power capacity. Scientific evidence for compound movement priority. The reason compound exercises like squats, deadlifts and bench press must come first extends beyond simply using multiple muscles. Norwegian School of Sports Sciences. Research showed testosterone and growth hormone release during compound movements was 5 to 8 times higher than isolation exercises. Testosterone levels measured after squats increased 25% above baseline, and this elevated hormonal state persisted for 3 hours throughout subsequent exercises. This means prioritizing compound movements maximizes the effectiveness of your entire training session. Compound exercises also activate central pattern generators, maximizing nervous system efficiency. Performing multi-joint coordinated movement patterns first enables more efficient muscle recruitment during subsequent isolation exercises. German Sports University Cologne research showed groups performing compound exercises first achieved 42% greater overall strength improvements compared to those starting with isolation exercises. This proves the nervous system activation effects of compound movements positively influence entire training sessions. The critical importance of large to small muscle group sequencing. Training large muscle groups like chest, back and legs before smaller ones directly relates to energy metabolism. ATP consumption during large muscle group exercises ranges from 3 to 5 times that of smaller muscles. If you fatigue small muscles like triceps or deltoids first, they become limiting factors in exercises like bench press or pull-ups. University of California experiments produced remarkable results. Groups training triceps before bench press could only handle 35% less weight than normal. Conversely, groups performing bench press before triceps training maintained nearly normal performance capacity. This occurs because small muscles serve supportive roles during large muscle exercises. When supporting muscles become fatigued first, prime movers cannot express their full strength regardless of their capacity. Therefore, maximum muscle growth requires training large muscles before small ones. University of Tsukuba meta-analysis showed groups training large muscle groups first achieved 28% greater overall muscle mass increases compared to those prioritizing small muscles. Priority strategies based on training goals. Exercise sequencing must vary depending whether your goal is strength, improvement or hypertrophy. For strength goals, exercises above 85%, 1 RM must be placed absolutely first. Maximum loads can only be handled when nervous system efficiency peaks. For hypertrophy goals, prioritize 70 to 80% intensity exercises, especially placing your target development areas first. University of Texas research showed muscle groups placed first in exercise order achieved 45% greater growth than others. For fat loss goals, prioritize compound and full body exercises to maximize caloric expenditure. Placing high-intensity interval training early creates excess post-exercise oxygen consumption, lasting 24 hours for maximized fat-burning effects. Optimal sequencing for upper-lower split training. When dividing upper and lower body training, sequencing remains crucial. During upper body sessions, train large muscles like chest and back first, followed by smaller muscles like shoulders and arms. Particularly performing bicep exercises after back training creates beneficial pre-fatigue for more effective stimulation. For lower body training, perform primary movements like squats and deadlifts first, followed by assistance exercises like leg curls and calf raises. Especially following squats with lunges or leg presses can create extreme metabolic stress in quadriceps for highly effective muscle growth. University of Melbourne research showed groups following proper sequencing during upper-lower splits achieved 32% greater muscle mass increases after 12 weeks compared to random ordering. Muscle interactions and synergistic effects. Complex interactions exist between muscles. Understanding antagonist and synergist relationships enables more effective exercise ordering. For example, performing back exercises after chest training enhances back muscle contraction through reciprocal inhibition. When one muscle contracts, the opposing muscle relaxes more completely, allowing greater range of motion in subsequent exercises. University of Copenhagen research showed alternating antagonist training increased each muscle's activation by 15%. Fascial connections also matter for exercise sequencing. Training along the posterior fascial line creates chain reactions, activating calves, hamstrings, erector spinae and neck muscles for more efficient movement patterns. Personalized exercise sequencing. Optimal exercise order varies based on individual fitness levels and recovery capacity. Beginners experience nervous system fatigue quickly, so should place only 2 to 3 most important exercises. First, keeping remaining exercises light and supportive. Intermediate trainees can prioritize 3 to 4 major exercises early, while using assistance exercises to address weak points. Advanced trainees can utilize pre-fatigue or post-fatigue techniques for more sophisticated sequencing strategies. Age is also important. After 40, longer mobility warm-ups are needed, with medium intensity exercises providing adequate preparation before high-intensity training. Older populations require longer rest periods between exercises due to slower nervous system recovery. Time-based optimal exercise sequencing. Circadian rhythms affect exercise effectiveness. Morning hours feature elevated cortisol, providing relatively high strength but reduced flexibility. Morning training should emphasize thorough warm-ups before prioritizing high-intensity exercises. Afternoon represents peak performance with highest body temperature and optimal neural transmission. Complex technical exercises or explosive movements work best when scheduled first during these hours. Evening hours begin parasympathetic activation, making moderate sustained efforts more appropriate than extremely intense training. Especially after 8 p.m., intensity should be moderated to avoid sleep interference. Strategic use of exercise order variation. Repeating identical exercise sequences causes adaptation and growth plateaus. Changing exercise order every 4 to 6 weeks maintains continuous progress through what we call order periodization. If chest was prioritized in the first cycle, prioritize back in the second cycle. This ensures balanced development, while creating opportunities to address weak points. During plateaus, completely reversing exercise order provides novel stimulus. Moving previously final exercises to first position can break through stagnation effectively. Exercise order and injury prevention. Proper exercise sequencing plays crucial roles in injury prevention. Activating core stability muscles before limb exercises significantly reduces spinal and joint injury risks. For knee injury prevention, activate hamstrings and glutes before quadriceps exercises. Overdeveloped quadriceps with weak hamstrings. Creates imbalanced knee joint stress, increasing injury risk. For shoulder joints, strengthen rotator cuffs and middle traps before large muscle exercises to prevent shoulder impingement syndrome. University of Basel research showed groups following proper sequencing had 60% lower injury rates. Nutrition timing and exercise order connections. Exercise sequencing closely relates to nutrition strategies. Prioritizing high-intensity exercises makes pre-workout carbohydrate intake more crucial. Adequate glycogen storage is essential for maximum high-intensity performance. Conversely, prioritizing low-intensity cardio enables fasted training for enhanced fat utilization. However, muscle breakdown risks exist requiring BCAA consideration. Post-workout nutrition timing also varies with exercise order. High-intensity first requires protein and carbohydrate intake within 30 minutes, while low-intensity first allows up to 1 hour. Subscribe, like, and hit notifications for more exercise science insights. Backed by cutting-edge research.